in the given question, a DC shunt motor is given with parameters given, that is VD, applied voltage is 250 volts with shunt field resistance of 250 ohms and motor resistance of armature resistance of 0.5 ohms. He had given that initially the motor is operating at N1 equal to 600 rpm with a constant torque and with a armature current of 20 amperes. Now he is asking us, if N2 is increased to 800 rpm, what is the shunt field resistance that is to be added, that is what is RF that is to be added is the question. Now once if I know what is the shunt field current, I can calculate RF easily. So our work here is to calculate our shunt field current. Now before going, it is given that torque is constant. Torque in a shunt motor is proportional to flux into current. Assuming that the flux is not going into saturation, torque will be proportional to field current into armature current. Now since torque is current, If1 into Ia1 will be equal to If2 into Ia2. What is If1? If is nothing but voltage across the winding, that is 250 by 250 ohms into 20 is equal to If2 into Ia2. From here I can say that Ia2 is nothing but 20 by If2, and also V equal to Eb plus Ia Ra, voltage equation. So Eb equal to Vt minus Ia Ra. So Eb1 is equal to 250, that is at n equal to 600 rpm minus 20 into 0.5, that is 240, and Eb2 will be 250 minus Ia2 into 0.5. Now dividing 1 and 2, Eb1 by Eb2 is equal to 240 by 250 minus Ia2 into 0.5. We know that in a motor E is proportional to 5 into N, that is nothing but E is proportional to If into N. So If1 into N1 by If2 into N2 should be equal to 240 by 250 minus Ia2 into 0.5. Now what is If1? If1 is already calculated, that comes out to be 1, and N1 is 600 rpm and N2 is 800 rpm. Since we want If2, let it be in If2. Now substitute this Ia2 in terms of If. What is this Ia2? Ia2 is nothing but 20 by If2. Now solving for If2, If2 will be equal to, two values will come, this is a quadratic polynomial, 0.739 ampere and also 0.0422 ampere. Since this is very small, it is absurd. Now considering If2 equal to 0.799, now R in the shunt field will be equal to 250 by 0.739, that comes out to be 338.29 ohms. Now my required RF will be equal to RF minus 250 ohms, that comes out to be 88.29 ohms. So to increase the speed from 600 rpm to 800 rpm, keeping the torque load constant, I have to add a resistance of 88.29 ohms in series with the shunt field. This is our answer.